Okay, we'll go ahead and get started. This is a live science session here today. Today is July 5th. I hope you all had a great holiday and thank you for joining today. My name is Amy Defoe. I'm one of the science teachers here with Graduation Alliance. And today I'm going to talk to you about some earth science and also a skill that we're working on. We'll be looking at comparing and contrasting. So just a couple heads up here. Again, I am one of the science teachers here at Graduation Alliance, so I may have you in my classes or I may not. But the same thing, we still use the same curriculum, and I'm still here to help you, provide you some information, some examples, and also answer questions that you may have too. Okay. These sessions are recorded, so I am recording this right now. So you have the option, as you can see, you can share your screen or you can share your face so we can see you face to face, which is nice. Thank you for sharing that. I like to see my students and see the faces that match you. You also have the option to turn your microphone off. So if you have some background noise going on or you might be interrupted, you're welcome to go ahead and turn that off. You can unmute yourself during the session if you have a question. Please do. I love the interaction during these sessions. So if you have questions or you want to give feedback, or if I ask you a question, I would love to have some students interaction here and helping me answer these questions as well. You can unmute yourself or keep yourself off on so that you can answer these questions. There is also a chat box where you can send me a message and I'll go through the lesson today. As I go through, I'll continue to check those messages as they pop up. So a couple different options, but again, these are recorded so that we can go back and if you missed a session or if you wanted to go back and review part of the session that we did, you have access to that. And also, in future sessions or future topics with other teachers, we're going to have a nice library full of resources of videos and live sessions that you can go back and use. So great. What we're going to talk about today is kind of we always have the same setup. Is I'll start talking about a science topic that goes along with one of the curriculums. So today we're going to look at the electromagnetic spectrum, starting off with the Big Bang Theory. And then after that, we'll have a moment to have questions. And then we'll do a skill. We're going to look at comparing and contrasting today in science, but we also know that we use it outside of science as well. And then I'll end the session with other questions. If you have a specific question about an assignment that's troubling you or a concept that you want more information, there'll be time for you to address that as well. So thank you for joining me. We'll go ahead and get started here. Okay, so the Big Bang Theory. So we think about the way that our science starts up is we first look at how was our planet created? Where did it come from? What is out in space and how did space get there? And scientists came up with this theory and they call it the Big Bang Theory. And you've probably heard the show, this is different, but the Big Bang Theory, it's kind of a funny thing because its name was a joke because if you think about the Big Bang Theory, yes, it's the theory that the universe came from a Big Bang. So a big explosion, expansion of space created our universe. And so as scientists were first looking into this, it was like, well, we'll just call it the Big Bang for right now. But it stuck because that's exactly what happened. So it states that our universe began by an expansion of matter and energy. And the two theories that support that is Einstein's theory of general relativity. And I'm sure you've all seen the picture of Einstein before. You've heard of him, scientists. Okay, he proved that gravity makes like a handprint or an indentation. So it leaves a mark in the fabric of space and time. Gravity isn't seen, but its imprint can be detected. Okay, so as a result of these indentations made by gravity in space and time, matter has been pulled together all over our universe. And over time, you guys know what that force is that's pulling or pushing down? Like right now, we're being pushed down by this force keeping us on Earth, called gravity. Over time, gravity eventually formed the objects in the universe we can see today. So in other words, when we think about, well, how did our universe come to be? It's gravity. Gravity is what formed the stars, the galaxies, and all of our solar system. So it was this force that drew in all of these particles together and created what we know as our solar system. The cosmological principle, so this is the second piece about it, It's not as well known as Einstein's theory, but it's still important to helping us understand the Big Bang Theory. The cosmological principle states that all matter is evenly distributed throughout the universe in the same amounts, moving at the same directions in the same waves. What that means is that matter erupted from a single point in space and time, and it's moving outwards. And the scientist, the famous scientist that helped study this and theorize this, his name is Edward Hubble. He's known for showing us that velocity, which is speed and direction of an object in the galaxy, it increases with its distance from the Earth. So he implied that the universe is expanding. This concept is known as Hubble's law. So as we can see, speed and distance, they are moving away from each other. Okay, I want to take a look at a little video to kind of explain a little bit more about this, and then we'll go into talking about the electromagnetic spectrum, and we'll talk about waves, and we'll look at the red shift and the blue shift and how that helps us understand the Big Bang Theory. Because if we think about it, with science, we're talking about a topic that, we can't just look out with our eyes out into space and get all the answers. We have to use tools and technology, and we have to help recreate this. So let's take a look at an example, see if it helps explain a little bit more information about this.